Now let's look at another problem where we're graphing a parabola written in vertex form. So to start with, let's look at the example. Y is equal to, let's say, 2x minus 3 squared plus 7. The first thing that you want to do is you want to identify the vertex. Now the vertex is simply going to be hk. And in this case, it's going to be positive 3, positive 7. Now let's think about that. The h is inside the function, so that's going to be just going to change signs, and the k is outside, so it's not going to change signs. So the vertex is hk, 3, 7. Then you're going to find the axis of symmetry. The axis of symmetry is going to be x is equal to, because it's a vertical line, the axis of symmetry is a vertical line, x is equal to whatever the x value is of the vertex. So in this case it's 3, so it's just x is 3. The second step that I do is I determine if this opens up or down. So I'll look at A. A is 2, and which means A is a positive number, which means it opens up. Another way to think that is this does not flip. The negative would flip it. So it opens up. So you kind of already know more or less what this looks like. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. There. It's going to open up. It's going to look something like that. The third step, what I try to do anyway, is to determine if this is going to be narrow or wide. And what I mean is narrow or wide relative to x squared. So let's look at A. A is 2. Let's take the absolute value of A. The rule is that the absolute value of A is greater than 1, then it's going to be narrow or narrower than x squared. And if absolute value of A is between 0 and 1, then it's going to be wider than x squared. In this case, A is 2, so the absolute value of 2 is just 2, so that's greater than 1, so this is going to be narrow, or narrower than x squared. So if you think about that, maybe it doesn't quite look like that, maybe it's even a little narrower, maybe it looks something like that. Now if you actually want to graph this, a lot of times you're just asked, what is the vertex or axis of symmetry, or does it open narrow or wide, or does it open up and down? Or if it's a multiple choice test, maybe you can figure it out from there. But the next step that you can do is you're going to find 2 points. And the way you're going to find 2 points is you're just going to do a table of values. And you can do as many points here as you wish. The more points, the just prettier graph that you get, essentially. Let's put the vertex in the middle. The vertex is 3 and 7. And now I'm going to choose 2 x's. And it turns out you can choose any 2 x's you want to, except for you want one larger than the x value of the vertex and one smaller. So you want one larger or more negative, one larger or more positive than 3. And one more negative. So let's see, let's choose 5, and let's choose 1. Now I chose the 5 at random. I just didn't want to choose a number bigger than 3. But once I chose 5, 3 to 5, that's 2 units, so I want to go back 2 units. And you don't have to do that, but that gives you some symmetry, that gives you a better sense of what the graph looks like. And now, once you choose the x's, you plug in x's to find the y's. And here you simply go, y is equal to 2, x minus 3 squared plus 7. Let's plug in a 1. So that's 1 minus 3 squared plus 7. Now you want to do it order of operations, so you want to do what's in the parentheses first, so that's a minus 2. Now after you do the parentheses, you have to do exponents, so that's minus 2 squared. Minus 2 squared is 4, positive 4. And then you want to do multiply, that's 2 times 4 is 8, 8 plus 7 is 15. Now you have to plug in the 5, and you get y is equal to 2, 5 minus 3 squared plus 7. 5 minus 3 is 2, so that's 2 squared. And what you'll notice is if you choose them so that these 2 points are equal distance from the vertex, then these 2 y values will also be the same. 2 squared is 4, that's 2 times 4 plus 7. Remember, you have to multiply first before you add, so that's a plus 7, so that's 15. Now what are you going to do? You're simply going to plot the points. Plot the vertex, the axis of symmetry, the 2 points, and sketch them in. Let's do that real quick. So the first thing we know is the vertex is 3, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. There's your vertex. Your axis of symmetry is simply going to be a horizontal line that goes through this point. So that's going to be x is equal to 3, x is equal to whatever the x value of the vertex is. Now you're going to choose 1 and 15. We may not be able to reach this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's going to be right there. But it's 1. And then it's also going to be 5 and 15. You know it's going to be a little bit flatter and then get steeper and steeper and steeper. A little bit flatter and steeper and steeper and steeper. You can label these 2 points if you wish. That's going to be 5, 15, and 1 and 15. And that's how you graph parabolas in vertex form. Let's do another one. Let's don't graph all the way through, but let's just look at it. Let's look at y is equal to minus 3/4, x minus 7 squared minus 2. The vertex here is going to be hk. So in this case it's 7 and 2. Now the 7 changes sign, so it's a minus 7 to a positive 7. The 2 doesn't change sign, so it's 7 and minus 2. The axis of symmetry is just x equals to whatever the x value of the vertex is, x equals 7. This one opens down. The way you know it opens down is the a is a negative number. And does this open to wide or narrow? Well, a is minus 3/4, so that's negative. So the absolute value of a will be positive 3/4, and that's between 0 and 1. And the rule is that the absolute value of a is between 0 and 1, then it's going to be wide. So you know this one's going to be wide. So even before you start graphing, you know more or less what this looks like. This is going to be 7 and minus 2. The vertex is roughly there. The axis symmetry is a vertical line through there. You know that it opens wide. So even without plugging in points, you know more or less what this looks like. Anyway, that's how you graph parabolas in vertex form.